So I had given you guys a problem yesterday, and that involved a supernode. So I hope you were able to solve.
Yes.
Okay. So maybe I'll just quickly run through it. Like, did anyone have any difficulty? Do you want me to explain, or do you want me to just go through it once before moving to the next one?
Yes, sir.
Okay. The yes is for explanation or the yes is for moving ahead? Like, if anyone wants me to just review that problem once again, I can do that. Or else is there anyone? Okay. Yeah, I have started the recording. Okay, since I think most of you are familiar with this, let's just move to the next problem. So we will do one more problem with this supermode nodes. Okay, supernode. Okay, that's going to be problem number 1 for today. So as I keep mentioning, please make sure that you are solving the problems in class. Those of you who are watching the videos after the class is done, please make sure that you are doing it as the class progresses. Okay, so this is the problem, and all the voltages, current sources, and resistors are labeled. Okay, so let's say this is V1, this is V2, this is V3, and this is V4. Okay, so the question is, find all the node voltages. Okay, basically find V1, V2, V3, and V4. Okay, V1 is fairly simple. You just have a voltage source there. So like yesterday, please work it out uh, during the class time itself, and put your answers in the box, in the chat box.
Sir, do we have to assume that the center of this, the center node is having zero potential?
Yes, yes. Usually that's what we do, right? Like if you have, okay, this circuit is looking a little different. Probably that's why you get the confusion. But that is like the reference node or the common node, and yes, you can assume that to be the ground node. So which two nodes form the supernode here?
V1 and ground.
Yeah, that is one. Is there any other supernode here?
V2, V3. V2 and V3.
V2 and V3. V2 and V3, correct. So let me just write the node equations. So V1 directly we can write it as 3 volt. Okay. And this can be your reference node, which is equal to 0. Okay. So V2 and V3 we can write a nodal equation, supernode equation. So 4 ampere is incoming here, and which is equal to V2 minus 3 divided by 1 plus V3 by 2, V3 minus V4 by 4. Okay, that's all. So this will be one equation. The other equation would be for V4. Okay, so at KCL at V4, what do you get? So all are outgoing currents. So we say V4 minus 3 by 2 plus V4 by 3 plus V4 minus V3 by 4 equaling 0. This is equation number 2. Okay. And what will be the third equation? You can relate V2 and V3. See, V3
V3
minus
minus
V2
V2,
is
0.5
0.15 of, yeah,
V
V3 minus
Vx,
V4.
V3 minus V4.
yes.
So this will be equation number 3. You can solve it. So has anyone got the answer? What is V1? Of course, is 3 volt. V2, V3, and V4. I hope you guys are using the calculator or some app
Yes,
to
sir.
solve the simultaneous equation and not solving determinants and so on.
Sir, is V2 4.2 volts?
Just a minute. Yeah, V2 is 4.2
and V3 4.5 volts,
Yeah,
and
I'm
And
not
V
writing the
four
second,
2.4
third
volts.
decimal point. Yeah,
Yeah,
I'm not writing the
and
second
V4
and
is
third
2.4.
decimal point because like as you, I mean, the way I solved it, like 1/3, I'll just put 0.33. Some of you might put just 0.3. Some of you might put 0.33343 and so on. Some of you may take actual fractions. So I'll just stop with the first decimal point. I think this is what, yeah, even I got it. I'll give maybe 2-3 more minutes for the others also to finish, and please to put it in the chat box if you are done. Yeah, 4.19, 4.21 depends on how you whether you have approximated or like how you have truncated the digits and so on. So like around the same, it's okay. So the reason I'm just going through it is because it's been like a year since you guys learned all this. So, and typically the way in which this course is taught is like, the part which you did in your first semester will also be merged into this course. Uh, so what happens? So all this will be kind of treated in detail, but just so that like everyone is on the same page, because we'll be using these techniques for the steady state analysis also later. And so I'm just giving you a kind of a, what shall I say, a refresher run here. Okay, if any concept is not clear, if anything is needs explanation or something, please do let me know. Okay, I'll definitely be happy to do that. Okay, so I think yeah, I can see that many of you are putting it in the chat box. Let's move. I'm assuming that there are no questions or doubts, right? Okay, so let's move to the next problem. Now this is going to be, okay, I'm not going to tell you what it is, but I guess you guys will easily do that. Let's do this just a minute. So let's, for warm up, let's just do a simple one first. Okay, so this is going to be I1, this is going to be I2. The question is determine I1 and I2. So it's a simple mesh analysis problem. The first one I've just deliberately made it, easier so that, you can just warm up to these concepts. It must be pretty long time since you guys did this. So how do we do mesh analysis? So let me just walk you through this so that those of you who have kind of forgotten, like you can remember. So we have two loops here. Okay, so first let's take loop number one. Okay, So if you're starting here, if you're going around like this, according to the convention, so when current if the current flow is in this direction, so if you have a resistor and the current flow is in this direction, the voltage drop will be like this, right? So if you say this drop will be like this, and you assume these drops to be like this, correct? Okay. So here, as you are going here, you have a minus first, so you say -6, and then you have plus 14 times I1, right? And then you come here, you have 5 plus, we can just add the 2, so it is 10, okay? 10 ohm into, what is the total current flowing through the resistors? It is going to be I1 in this direction and I2 in this direction, right? This is I1 and this is I2. So the effective current that is flowing is I1 minus I2. This is equal to 0. So this is your first equation. If you look at loop number 2, what do? Let's say we start from here. So here again but here what do? You assume that I2 is stronger. So you say 10 times I2 minus I1. Okay. In the next analysis, let's say you're going to put, this is the direction in which the drops are. Okay. Because the current is flowing in this loop. So it is 10 times I2 minus I1 plus 10 times I2 plus 5 equal to 0. Okay. These are the two equations and you solve them. Yeah, the answers are right. So I1 equals, what is it, 184 milliamp, 184.2 milliamp. I2 equals minus 157. Yeah, 157.8 or 89, whatever. Yeah. Okay. Is it clear? Anyone has any doubts about mesh analysis and so on? No doubts? Okay, that's good. All right. Which means that I think we can move to the next problem. Okay. So let's do this one, or rather, what shall I say? This is 7 volt. Okay, and you have 1 ohm. Then you have 2 ohms. 3 ohm. You have a 6 volt supply. 2 ohm. Okay, so this is the circuit, and let's define the currents. This is current I1, this is current I2, and this is current I3. Question is, determine all this: I1, I2, and I3.
Sir, I1 and I3 are 3 amps and I2 is 2 amps.
Just a minute. Yeah, I1 and I3 are 3 amperes.
And I2 is 2 amps.
Correct? Yeah. Okay, good. All of you are getting this equation. Sorry. All right. So all of you are getting this one. That's good. Okay, fine. Let's move to the next problem. Okay. So if there are any doubts, just let me know. Okay. So just like how we had a super node. Okay. When do we have a super node? When you have a voltage source between two nodes. And the problem, let me just move to that particular slide. Okay. So in this case, if you take, let's say this particular pair of nodes, there is a voltage source, right? And we don't know what is the current through that voltage source. So one option would be that you assign an unknown current and then solve it. And so you'll have 4 equations, 4 unknowns, or and you will have a more elaborate solution, right? That is the longer way to do it, and the easier way to do it is to just take it as a super node, because whatever current is going out of V2 will anyway come into V3, and so you combine the two nodal equations and you find that, and you find the solution, and that is the easier job. Now a similar situation happens in the mesh analysis also, what is called a super mesh, right? I hope all of you are familiar with super mesh. Yes?
Yes, sir.
Yes.
Yes. Okay. All right. So so analogously, what is a super mesh?
Sir, when in a branch there is a current source.
Correct. So when in a branch you have a current source and you need to figure out how to, so there are two options. So let me give you this problem here. Okay. Uh, 10-volt source, and then you have 4 ohm, 5 ohm, 9 ohms. Okay. So this is 1 ohm, this is 7 ohm, this is 3 ampere. Okay. And the question is, find out what is I1. Now if you see here, like if you try to write a KVL equation around the first loop, you have this current source, right? You don't know what is the voltage across the current source. So the first option is basically, what is the first option? You assume,
Voltage.
yeah, assume a voltage across the 3 amp current source and solve like 4 equations with 4 unknowns. This is a very laborious process. So the other option is basically to use a super mesh. What is a super mesh here? Just to refresh your memory, you form a loop which does not include the current source, or rather the current source is enclosed in the loop. Okay, so one such loop can be something like this, right? So you can have a loop which is like this. So where the current source is included, but like it is not, it doesn't form a part of your KVL equation. So both the mesh equations are combined into one super mesh equation, and then you solve them. So you have two equations with two unknowns, and you can find the answer. So can you solve and let me know what is I1? Okay, the answer is around 1.93, or sorry, minus 1.93 ampere. Okay, so you take this mesh equation and then you take this mesh equation, and then you, let's say this is I2. Let's say what is flowing here is, let me use a different color. What is flowing here is I3, and then you say that I1 minus I3 is basically minus 3 amp. Okay, so are there any doubts, any questions? So is this clear? All right. So let's solve one more problem in the class, and maybe I'll give you an assignment by the end of today, which you can try to practice and solve at home. So let's move to the next problem. Okay. So with this, we'll kind of complete our overview of nodal and mesh analysis, and from next class onwards, we will start looking at other things. So you have already studied Norton equivalent, Thevenin equivalent circuits, right?
Yes, sir.
Yes. Okay.
Sir,
So yeah.
sir, we won't be dealing with complex complex impedance and stuff like that.
We will be doing. Actually, that is the main part of this course. So this is just an kind of brush up of the. So you have already done the nodal and mesh analysis with complex numbers, with complex currents,
Yes.
voltages.
Very few examples, sir, very few. Not
Okay.
intensively, because
Okay.
it is lengthy. So they put some questions in the test. That's why.
Okay. Okay. Yeah. So actually, we will be looking at it in greater detail this time. So if you guys are all totally comfortable with Thevenin and Norton equivalent circuits, then I will not go through them. I just wanted to have a review of nodal and mesh analysis because that is something essential, and I think I will skip all the other stuff that you have already done. And probably, have you done RLC circuits? RLC circuits?
Yes.
Yes. Okay.
So we need a
Have you?
recap of that as well.
Okay. Okay. So we'll.
Steady state.
You did only steady state.
Yes, sir.
Okay. The forced response, natural response, all those things have you covered? Like the exponential decay, exponential rising.
Sir, in case
No,
of
sir.
DC RNC.
So we
Okay.
haven't actually.
Okay.
No,
Okay. So probably that is the actual part to be covered in this course. So I just wanted to know how much has been covered there and how much has been covered here. So probably next class I'll start with the RLRC part, or maybe we'll just go through some inductor, capacitor circuits. Okay. All right. So for the last problem for today's class, let me give you this problem. So if any of you have any doubts or questions with or if you are not clear on any aspect of nodal and mesh analysis, because this is the foundation for everything else that you will be doing. Okay. So make sure that you are clear. Okay, so this is the circuit, and the question is basically determine the power absorbed by the 10 ohm resistor. Okay, so we barely have about like 3-4 minutes to go. So start solving. If you have doubts, you can ask. Complete this problem, and probably we can discuss the answer next class.